So if we just need to solve here, right? Get x by itself, right? Subtract 3x from both sides. So negative 21 equals 7x. Divided by 7. So x equals negative 3. I do want you guys checking your answers, to see, especially this idea of extraneous solutions. We've talked about that before. How sometimes an answer just may not work, even though you didn't do anything wrong. You guys should always be checking your answers. And the same rules apply as far as checks go. You always go back to the original problem. You always don't move anything across the equal sign. You should always be simplifying. So 3 times 5 times negative 3 is supposed to be equal to 2 times negative 3 minus 7. Which would be 3 over negative 15. So if I just simplify that, both are divisible by 3, so that'd be 1 over negative 5. And then this would be 2 over negative 10. Both of those are divisible by 2, so that'd be 1 over negative 5. So there's our confirmation that negative 3 is correct. And again, visually, again, you guys don't need to do this, but basically what that means is that we've just found the point where they do cross. So one of the lines is doing this, the other one's doing that. So we just found that point that negative 3 1/5 is where they would cross. So that would be the x value. And then when you plug x in, you get 1/5. Negative 1/5, that'd be that should be down there, shouldn't it? Negative 1/5. That should be down there, but that'd be where they cross. So just that's what it means. That's what we're up to. Again, you guys don't need to draw that, but that's what we're doing. So why don't you guys try this second one here? And 3 equals negative 3 on your all's end. Like, okay, Jubal, Sophia? Tion, you good? All right. Yeah. Roll is taken. All right, so those are like really basic ones. We're going to step up the complexity here a little bit. Next one. Same idea though. Okay, everything we do today is going to be the same 2 steps. Cross multiply and then solve. Okay. And my personal habit to take the top left by the bottom right first. So that's easy. That's 11x plus 8. And top right, bottom left second. So x times 2x would be 2x squared, and x times 5 would be 5x. So just want to notice at this point how this equation is different than the last two, right? So both of these last two, when we got to this point, after our cross multiplication, we have just x's and constants. So in order for us to solve that, we want to just get x by itself, right, as our goal. Well, how do we get x by itself if there's multiple types of x's? Something we've explored before, that we need a different way to approach this problem. How do we get x by itself with a problem like this? So in the end, we need to do some factoring. Okay, so but in order for us to do factoring, what do we have to do first? Yeah, we need one side to be 0. So because we can't separate the x's and figure out what x is, we have to instead collect all the x's on one side, and that way actually collect everything on one side. So, so you have multiple types of x's. You want to set one side to 0, and then we're going to look at some factoring. So when we say something like solve, right? Solve is a pretty nebulous or ambiguous statement. There's a lot of things that involve in solving, right? And so we just have to be aware of what's going on in the problem. So You always want to keep this term positive, that square term positive. So move things to the right, not to the left. So I'm going to subtract the 11x and subtract the 8 to the right side. I get 0 equals 2x squared minus 6x minus 8. So we have to take a different approach to solving, and then even when we say something like factoring, that's still a pretty nebulous thing because we've talked about lots of different types of factoring. What type of factoring should we always look at first? We always want to see if there's a GCF first. It doesn't always going to be one, but we always want to check to see if there is one first because it's going to make the rest of the problem easier. And then after that, and Caleb said earlier that AC is going to be your go-to thing here. I really think, as far as what I saw, homework and stuff like that, these two guys are the only ones you really need to worry about. I didn't see any difference in squares or anything like that. No, certainly no difference in sums of cubes. Won't be anything you guys need to worry about. So, but always look for a GCF first, and then try AC method after that if you need to. If we weren't to do the GCF first on this problem, it wouldn't be too bad because 2 times 8 being negative 16, that would be our AC, and factoring negative 16 is pretty easy. But a lot of times, that number can get pretty gross if we're not careful. So I still want to just do this the right way, which is going to mean to take a GCF out first. So everything there does have a 2 in it, so I'm going to take that 2 out. So 2 times x squared and 2 times negative 3x and 2 times negative 4. So actually do something, because that's just a 2. Okay? There's no x with it. We can actually just completely go ahead and get rid of it. Okay? That 2 has no effect on the answers to this problem. The answers are here where the x's are. The answers to this are going to be the exact same as the answers to this. So that 2 has no effect here. So I'm just going to go ahead and actually divide it to the other side, which has the wonderful effect of just making it go away completely. So that 2 is gone now. So now we want to think about the AC method, right? A times C, so 1 times negative 4. We need the factors of negative 4. It's been a little while since we talked about AC method. Factors of negative 4. The add to our B value, negative 3. We need 2 numbers that multiply to be negative 4, but add to be negative 3. One and negative 4. Yeah, so 1 and negative 4. It doesn't matter which order you write those in. Don't lose track of your 0 though. So x squared. So if you want to write the 1 first again, that'd be 1x. Make sure I write plus x, and then minus 4 second would be minus 4x. Remember, what we're really trying to do here, guys, we're trying to break that negative 3 apart. Right? We found a unique way, a special way to break that negative 3. That was our job there. That's why we need those x's. This negative 3x we're talking about here. Once we have it broken, that's when we go and do our factoring by grouping. So x squared and x both have an x in them, so we take that GCF out. X times what is x squared? X times x. X times what is x will be x times 1. Oftentimes when it's like an x and an x like that, people will just cut it off and be like, that's done. Except for x times x is not x squared plus x. That doesn't work. Okay. So we do need that 1 there, as silly as that seems. And then these two, what do they have in common? Remember that first term's negative, always take out a negative. They both have negative 4 in them. So take out negative 4. Negative 4 times what is negative 4x? Negative 4 times x. And negative 4 times what is negative 4? Will be negative 4 times 1. Remember, this problem is talking to us. It's saying, hey, these are the same. That's good. Everything's working. If you pick the wrong numbers here, you go and continue factoring, these will not turn out to be the same. Okay? Or if the problem just wasn't factorable, period, these won't turn out to be the same. So let this talk to you. Don't force them to be the same. Let it happen on its own, and that let you know that things are going well. So the x plus 1s go together, and then the x minus 4 go together. So there's our factors of this. Of course, we know that we're supposed to set this equal to 0 and solve it, but we know that we can just change the sign. We have a little shortcut that we know to take advantage of. And that's the real math, is we're supposed to set that equal to 0 and say, and solve it. I'm okay if you guys jump to there. It's easy enough. So we have two answers. So we need to check to make sure they both work. We always go back to that original problem. Check both answers. Since I'm doing blue, I'll check the 4 first. So I got 1 over 2 times 4, which would be 8 plus 5 equals 4 over 11 times 4, which is 44, plus 8. I'll finish that math in a second. I'm going to just write out the other one. Check. Got 1 over 2 times negative 1, which is negative 2, plus 5. Negative 1, which is 11 times negative 1, which is negative 11, plus 8. There, I'm just going through and plugging the numbers in. What's that? Why is there a 1 there? Oh, that's from here. That escaped. So we get 1 over 13 equals 4 over 52. And 52 divided by 4 is 13, so it reduces to 1/13 also. So 1 over 13 equals 1 over 13. So 4 works. And then 1 over 3 equals negative 1 over negative 3. Of course, negative 1 over negative 3 is equal to 1 over 3. That also works. No extraneous solutions there. They both work. Okay, Mason? All right, Jarrett? June? Okay. Get another one together. So there's another little layer of complexity. We've got more x's, right? So this. I think this one will be the worst of the bunch, but it's really not that bad. As we go to do that multiplication, I'm going to write this one out because I can't do that in my head. I don't know if you guys should be doing that. Try to do that in your head either. 10x plus 16 times x minus 1. Now work through your distribution here. It'll be 10x squared minus 10x plus 16x minus 16. Find those like terms. So it'll be 10x squared plus 6x minus 16. So there's our left side. I'm going to do that right side. And distribution here, 2x squared plus 2x, 8x plus 8. Finding like terms gives us 2x squared plus 10x plus 8. Yeah, once you guys are done with that, cross multiplication, you should kind of be stopping and evaluating the problem, saying what's my next step going to be? Can I just get x by itself simply, or do I need to be thinking about factoring? So what you should be keying in on is, are there multiple types of x's in the problem? So x squareds and x's. Means factoring needs to be part of your problem. So one side needs to be 0. Always try to keep that x squared term positive. Okay, you want that to stay positive, so move things towards this, not towards this. So I'm going to move everything to the left this time. Subtracting 2x, subtracting 10x, subtracting 8. 8x squared minus 4x minus 24. Kyla, Addison, you guys doing okay? So GCF, we should always look for that first. Again, the real reason why we need to do that is very apparent here. If we did AC right now, we'd be taking 8 times 24, which is 192. We're trying to find the factors of 192 that have to be 4. Okay? Not too familiar with my factors of 192. But if we say, hey, those all have a 4 in them, and if we take advantage of what happened last time, we took that 2 out, but then we just got rid of the 2 right away, let's go ahead and do that right now. Let's do it in one step. Let's take a 4 out of everything, but instead of factoring it out, let's divide it out. Why this is okay is because we're solving for x. This is not a factoring problem. The goal here is not to factor. The goal here is to solve, and that's just a 4. It's not a 4x. If there was an x there that we were trying to take out, this would not be a good idea. Since we're just getting rid of a coefficient, it's okay to do this. Now if we look at our AC, 2 times 6, our AC is negative 12. So much simpler AC method problem now that we've gotten rid of those 4s. That's why it's so important to look for those GCFs first. Okay, so we divide it out. Look at our AC. A times C is negative 12. And negative 12 to add would be negative 1. So what are our factors of negative 12 to add to be negative 1? Negative 4 through. So 2x squared minus 4x plus 3x minus 6 equals 0. Don't lose that equals 0. It is an equation you're trying to solve. If you don't have an equal sign, it's kind of hard to solve it. Can't solve an equation that's not an equation. Sam, what are those 2 first terms have in common? 2x. And then 2x times what is 2x squared? Jump ahead of me. Yep, 2x times x, and then 2x minus 2x times negative 2. Cool. Jordan, what about the second 2? What do they have in common? 3. So make sure when you're taking out that 3, you're taking out a positive 3. Should have a plus sign in front of it. 3 times what is 3x? And 3 times what is negative 6? So x minus 2 again, let that happen on its own. Don't force it. Let it tell you that things are going well. 0. X minus 2's come together, and then the leftovers, the 2x and the 3 come together. So of course your x equals 2. If on the 2x plus 3 you need to write it out and solve it, in a 2-step equation, then go ahead and do that. If you can do that in your head, go ahead and do that in your head. We need to subtract 3 over. Need to divide by 2. And definitely, previously, guys, I would have said stop there. Leave your answer as a fraction. Because we need to go and plug that back in, we probably don't want to plug a fraction back in. So I'd say let's go ahead and just rewrite that as a decimal. Okay. That's going to be a lot easier to check as a decimal. You guys shouldn't be getting any gross decimals for your answers. They should be like halves. If that had been like 2/3, we would not want to write that as a decimal because that would involve us rounding. Any rounding we do right now is not going to check well. Okay, so, but I don't think you guys should see any bad fractions, especially if you get anything really weird. I don't even think you guys should see any like repeating fractions, like 1/3 or 2/3, anything like that. The ones that we saw that I checked last night were like halves, so easy enough to plug back in. So let's check those before we move on. Make sure nothing's extraneous. So check 2. So 2 times 10 is 20 plus 16 over 2 plus 4. 2 times 2 is 4 plus 2, 2 minus 1 on the bottom. Yeah, I'll come back to that in a minute. I just want to write down this work first. Uh, 10 times 1.5 would be 15, so that's going to be negative 15 plus 16. And negative 1.5 plus 4. And 2 times 1.5 would be 3, so that'd be negative 3 plus 2, and negative 1.5 minus 1. Of course, 20 plus 16 is 36 over 6, which equals 6. And over here I get 6 over 1, which of course is 6. So 2 works nicely. On the purple one here we get 1. 4 minus 1.5 is 2.5. On top here we get negative 1. And negative 1.5 minus 1 is negative 2.5. You can see that those sides are equal to each other, right? 1 over 2.5, whatever that's equal to, it's equal to itself. Okay? So you don't have to know what the number is in order to know that it's equal to itself. So that also works. So no extraneous answers yet. But that would be equal to like 0.4. So 0.4 would equal 0.4. That one was by far the worst one of the bunch. This next one's actually much simpler. Last one we're going to do. So we still haven't seen an extraneous solution, and we will see that finally here on this last one. What that looks like. No, but all of that stuff is stuff you guys have done many, many times. I mean, distribution, combining like terms, all that stuff, solving quadratic equation. This new bit here with this dividing the GCF out, that's new, but hopefully it's not too big of a deal. Solving quadratic equations is something we've done multiple times. Checking is be a little intense sometimes. It hasn't been too bad so far. Last one. This one's really actually pretty simple. So top left times bottom right would give us 2x squared minus 2x. Top right times bottom left will give us 3x squared minus 6x. Super easy thing to do is miss your distributions. Be really careful about that. Stop and I'm going to look and say, okay, I've got 2 types of x's here, x's and x squareds. So I want to gather them. Always move them towards the bigger of the 2 x squareds. So I'm moving everything to the right this time. Minus 2x squared plus 2x. That leaves me with x squared and then minus 4x. I always start with GCF factoring first. Even if I wanted to do AC method here, I can't because there's no C. How to do the AC method if there's no C in the problem. So looking at GCF, those both have an X in them. So bringing that X out would be X times X minus 4. And the factoring is actually done. One more factoring there, which is why this problem is so easy, because the factoring was really easy. Recognize there's no factoring because there's no more squares. Right? There's nothing else to break down. Or each one of these is supposed to be equal to 0, so X equals 0, and X equals 4. So those are our answers we're going to check. So checking 0. So 2 over 0 squared, of course, is 0. 2 times 0 is 0, so 0 minus 0. And 3 over 0 squared minus 0. And checking 4. 2 over 4 squared is 16, minus 2 times 4 is 8. 3 over 4 squared is 16, minus 4. So on the top here, I get 2 over 0 equals 3 over 0. Well, what's 2 divided by 0? 0? We get into groups of 0? Let's get into groups of 0, guys. This means take two things and then make them into groups of 0. What's 2 divided by 0 equal to? Can we get into groups of 0? If there was 10 of, if there's 6 of you, and I said, hey, get into groups of 2, right? That means there's going to be 3 groups of 2. Or if I said, get into 2 groups, that'd be 2 groups of 3. Right? 6 divided by 2 is 3, because we can group 6 into 3s. But can we group 6 of you into groups of 0? Can't. I don't know what happened over here. But that's a really common mistake. But it's really, it's a basic fact of math that you can't divide by 0. Division by 0 is undefined. So this is why this answer is extraneous. When we plug that answer in, it made the denominator 0. That's what makes a rational function extraneous, is that the denominator becomes 0. So it's different than what we saw with the last set of problems we were doing when we got extraneous solutions, where we had one that was like 3 and the other one was negative 3. We knew that was like, okay, I couldn't do anything about that. It was just going to happen on its own. This is what happens. We can't do anything about this. We did all the math right. We still get this answer that doesn't work because it makes the denominator 0. And it has nothing to do with it being 0. Okay, 0 is a fine answer. Just can't be an answer to this problem, because it makes that 0 or it makes this 0. If we looked at the last problem, x couldn't have ever been negative 4. If x had been negative 4, we would have had a problem. Or if x had been 1, we would have had a problem. So 0 is an okay answer, just not for this particular problem, because it makes that 0. Okay? So don't just think 0 is a bad answer all the time. If the denominator itself is 0, that's bad. Okay? So like we got 4 here, if we got 4 on the last one, or negative 4, I guess, that would have been bad. Okay? So we go to check the other one. We get 2 over 8, which of course is 1/4. Here we get 3 over 12, which is 1/4. So 4 works. So extraneous versus wrong. Okay? So extraneous means one side is 0. Wrong would be, you work it down and it's like 2/3 equals 4/5. That's incorrect. Okay. So when they're completely different numbers, whether it's 2/3 and -2/3, like, or if it's 2/3 and something completely different, that's just a wrong answer. That's you guys saying, okay, I messed something up, and how do I go back and fix that? Okay. Versus, this was never going to work no matter what. That wasn't my fault. I got the answer. It just wasn't going to work. Okay. So again, you guys get this. You should be saying, hey, Mr. Baker, or you should be trying to find your error, which is generally very tough because your brain made the mistake. Your brain's generally going to make the same mistake over again. Usually it's a sign you missed or a little multiplication you missed or something like that. But you guys should be saying, hey, here's what I got. I know it doesn't work, but I can't figure out what I did wrong. That's what I want to hear from you guys. Versus calling this extraneous when it's not. That's bad. Okay? So it's only when it's the denominator 0 is that extraneous for a rational function. Okay? So just watch out for that. And that's the factoring kind of is the key to this stuff for those more difficult problems. The thing that's in your Google class for homework is just posted a PDF. I didn't even set it up as a worksheet because I really prefer you guys just do it on a piece of paper, just like we just did the notes. So there's nothing special about this stuff where you guys need a worksheet for it. So, but there's a daily point there. There's a spot for your homework already made. Yeah, so hopefully it's not too bad. Make sure you're checking your answers. It's really a big thing, guys. And I'll let you guys know tomorrow about Wednesday. Yeah, it's closed because I closed it. I close all the quizzes when you guys after you take them, so that they're kind of locked down. So you should be fine. 25.